The Sun, a star at the heart of our solar system, is a giant ball of burning plasma. It dwarfs our planet, with a diameter over 100 times larger than Earth's. Imagine holding a basketball next to a small pea. That's the size difference we're talking about. The Sun's surface temperature is a scorching 5,600 degrees Celsius, or 10,000 degrees Fahrenheit. This intense heat is generated by nuclear fusion reactions occurring deep within its core. Hydrogen atoms are constantly fusing to form helium, releasing unimaginable amounts of energy in the process. This energy is what powers our entire solar system, providing light and warmth to Earth and other planets. The sheer scale and power of the Sun make it a force to be reckoned with. Earth, the blue planet, is blessed with an abundance of water. This life-giving liquid is found in various forms and locations across our planet. Oceans, lakes, rivers, and ice caps cover over 70% of its surface. These vast bodies of water are not just scenic wonders, but are crucial for sustaining life. It's estimated that there are about 1.3 quintillion liters of water on our planet. This staggering amount of water is distributed unevenly, with the majority found in our oceans. To put that in perspective, imagine 554 trillion Olympic-sized swimming pools filled to the brim. This comparison helps us grasp the sheer volume of water present on Earth. That's how much water we're talking about. This immense quantity is vital for various processes, from weather patterns to supporting marine life. If we were to spread all this water evenly over the contiguous United States, it would create a layer over 30 centimeters or 1 foot deep. This visualization underscores the vastness of our water resources. This precious resource is essential for all life on Earth. From the smallest microorganisms to the largest mammals, water is a fundamental necessity. It sustains ecosystems, regulates our climate, and allows us to thrive. Without water, our planet would be a barren wasteland, incapable of supporting the rich diversity of life we see today. The sheer volume of water on our planet might lead one to believe it could have significant effects elsewhere in the solar system. However, Earth's unique conditions make it the only known planet with such abundant liquid water, making it truly special. The Sun sits at the center of our solar system, approximately 150 million kilometers, or 93 million miles, away from Earth. This vast distance is almost incomprehensible when you think about it. The Sun, a massive ball of burning gas, provides the energy that sustains life on our planet. Its gravitational pull keeps the entire solar system in balance, ensuring that planets, moons, and other celestial bodies follow their orbits. To put this distance into perspective, imagine traveling to the moon and back. You would need to do that 400 times to cover the distance to the Sun. The moon, our closest celestial neighbor, is about 384,400 kilometers away from Earth. This means that the journey to the Sun is not just a simple trip, it's an expedition of unimaginable proportions. The Apollo missions, which took humans to the moon, were monumental achievements, but even they pale in comparison to the challenge of reaching the Sun. Reaching the Sun is no easy feat. The journey requires overcoming numerous obstacles, including the intense heat and radiation emitted by the Sun. Spacecraft must be designed to withstand these extreme conditions, which is no small task. The technology needed to protect instruments and equipment from the Sun's harsh environment is incredibly advanced and constantly evolving. It requires an immense amount of energy to break free from Earth's gravitational pull and propel a spacecraft towards the Sun. The energy needed for such a mission is staggering, and the engineering challenges are equally daunting. Rockets must be powerful enough to escape Earth's gravity, yet precise enough to navigate the vast distances of space. Even the Parker Solar Probe, the closest a human-made object has ever gotten to the Sun, still orbits at a safe distance of several million kilometers. This probe, launched by NASA, is designed to study the Sun's outer atmosphere and gather data that will help us understand more about our star. Despite its proximity, the Parker Solar Probe must endure temperatures of up to 1,377 degrees Celsius, a testament to the extreme conditions near the Sun. Transporting even a small fraction of Earth's water to the Sun would require an unimaginable amount of energy and resources. The logistics of such an endeavor are mind-boggling. Water, essential for life on Earth, is incredibly heavy and difficult to transport in large quantities. The energy required to lift it off the planet and send it towards the Sun is beyond our current capabilities. It's a logistical nightmare that simply isn't feasible with our current technology. Scientists and engineers are continually pushing the boundaries of what is possible, developing new materials and propulsion systems that may one day make such missions a reality. However, for now, the journey to the sun remains a dream, a testament to the incredible challenges and wonders of space exploration. Let's imagine for a moment that we could somehow transport a small amount of water, say a glassful, to the sun. What would happen? The moment that water approaches the sun, it would be met with unimaginable heat and radiation. The water molecules wouldn't stand a chance. They would instantly vaporize, turning into steam before being ripped apart into their constituent atoms, hydrogen and oxygen. The sun's immense gravity would then pull these atoms towards its core, where they would be subjected to the intense pressures and temperatures of the solar furnace. In the grand scheme of things, a glass of water wouldn't even make a ripple in the sun's vastness. Section 5. Fanning the flames, water meets fire. Now let's scale things up. What if we were to somehow transport all of Earth's water to the sun? Would it be like dousing a campfire with a bucket of water? The answer, surprisingly, is no. In fact, pouring all of Earth's water on the sun would have a negligible effect. The sun is simply too massive and too hot. The water would instantly vaporize and dissociate into hydrogen and oxygen. These elements, already present in vast quantities within the sun, would simply fuel the ongoing nuclear fusion reactions, making the sun burn even brighter. It's like trying to extinguish a raging inferno with a spray bottle. Section 6. Global warming, a different beast. Some might wonder if pouring water on the sun could somehow mitigate the effects of global warming here on Earth. After all, the sun is the primary driver of our planet's climate. However, this idea is based on a fundamental misunderstanding of global warming. The problem isn't that the sun is getting hotter. It's that human activities, particularly the burning of fossil fuels, are releasing greenhouse gases into the atmosphere. These gases trap heat and cause Earth's average temperature to rise. Pouring water on the sun wouldn't address the root cause of this problem. It's like trying to fix a leaky faucet by yelling at the rain. Section 7. The logistics of water removal, a titanic task. Let's delve into the logistical nightmare of actually removing all of Earth's water. Where would we even begin? We would need a fleet of colossal pumps, pipelines, and storage tanks unlike anything ever conceived. Imagine trying to drain all the oceans, lakes, and rivers with a single garden hose. It would take billions of years. Even if we could somehow overcome the engineering challenges, the energy required to lift and transport this astronomical volume of water into space would be staggering. It would require harnessing a significant portion of the sun's energy output, which is currently beyond our technological capabilities. Section 8. A thirsty planet Earth without water. The consequences of removing all of Earth's water would be nothing short of catastrophic. Life as we know it would cease to exist. Oceans would transform into vast, arid deserts. Marine life, from microscopic plankton to giant whales, would perish. Land would be scorched and barren. The delicate balance of our planet's ecosystems would be irrevocably shattered. Without water to regulate temperature, Earth's climate would become even more extreme. Days would be scorchingly hot, and nights would be freezing cold. The once thriving blue planet would become a desolate wasteland. Section 9. Cosmic what-ifs, alternative scenarios. While pouring Earth's water on the sun is an impossible feat, it's still fun to ponder other hypothetical scenarios. These thought experiments allow us to stretch our imagination and explore the boundaries of our understanding of the universe. They serve as a reminder of the vastness and complexity of the cosmos and our place within it. What if, instead of water, a celestial body made entirely of water, a planet-sized water balloon collided with the sun? This scenario, while equally implausible, opens up a fascinating discussion about the interactions between different celestial bodies and the sun. The sheer scale of such an event would be beyond anything we could ever witness on Earth. Such an event would undoubtedly be spectacular. The collision would create a dazzling display of light and energy, visible across the solar system. It would be a cosmic fireworks show, with the sun at the center of the spectacle. The water would instantly vaporize upon contact, creating a massive cloud of superheated steam. This steam would expand rapidly, potentially affecting the sun's outer layers and causing temporary changes in its behavior. The dynamics of such an interaction would be a fascinating subject for astrophysicists to study. This could potentially lead to increased solar activity, such as solar flares and coronal mass ejections, which could have implications for Earth's magnetic field and communication systems. The increased solar activity could also affect space weather, posing challenges for satellites and space missions. However, even a water planet many times the size of Earth wouldn't be enough to extinguish the sun. The sun's immense energy output and gravitational pull would ensure that the water vapor is eventually dispersed, leaving the sun relatively unchanged. This highlights the incredible resilience and power of our star. The sun's immense gravity and energy output would eventually dissipate the water vapor, leaving the sun relatively unchanged. The sun's core, where nuclear fusion occurs, would remain unaffected by such an event, continuing to produce energy as it has for billions of years. These thought experiments highlight the incredible scale and power of the sun compared to our tiny planet. They remind us of the vast differences in size and energy between celestial bodies and the sun, and the limitations of our human perspective. They remind us that while human ingenuity knows no bounds, there are some forces in the universe that are simply beyond our control. The sun, with its immense power and energy, is one such force. It serves as a humbling reminder of our place in the cosmos. The sun will continue to burn for billions of years to come, a testament to the awe-inspiring forces that govern our universe. Its energy sustains life on Earth and drives the dynamics of our solar system, making it a central figure in our understanding of the cosmos.